I'm now recording. Let me give Ramsey control. Perfect. All right. Before we get started, okay, here's a scenario. Okay, and Ramsey, feel free to take out a pen and a piece of paper to write this down. I think somebody is coming into the room. I gotta let them in. Carlos, oh my man. Let me go ahead and let him in. All right. So here's a scenario. We have 3 buildings for Claude's TV and VCR store. Okay? Business is thriving. We are now selling Roku TVs or what have you, right? But that doesn't matter, right? We just need you to design our network, right? So we can have connectivity throughout different sites, okay? And within the site, okay? So each site, 2 floors, okay? And each floor has 22 to 36 users. We need 2 or 3 APs on each floor, okay? Running at both 2.4.
Yep.
Ramsey, I'm good, or you want me to keep going?
I have 22 to 36 units on each floor. There's 3 buildings, 2 floors each building.
So let me repeat that again. So I have 22 to 36 people who will be using laptops that need to be connected directly using a wire on each floor.
Yes.
Okay. I also need at least 3 APs on each floor that supports 2.4 and 5 gigahertz.
And
okay. This is for all 3 buildings. Okay.
Copy.
The distance between each building, building 1 and building 2, is only 8 kilometers.
Copy.
Okay. Building 1 to building 3, 50 kilometers.
50.
Yep, 50.
Now I'm going to add this as well.
The
buildings, okay, since my company is somewhat small, but to me it's a big expansion, but in the grand scheme of things, it's still small. So the dynamic protocol that we're going to use to link these buildings, single area OSPF.
Yes.
Okay.
Okay.
Copy.
Ramsey, I also need, within my building, I need redundant switches on each floor in the case of a failover.
Copy that.
I need you to account for spanning tree.
1 second.
I also need.
Hold on, Dave.
Go ahead.
Hold on.
Each floor. 1 second. Each floor. Okay. Yeah. Redundant switch on each floor.
Okay. All right. And I need you to implement some security on the user side, and I need you to implement some security just in case we have some rogue PCs or rogue servers implemented within this environment.
Copy that. Server.
Claude, am I missing anything?
No, I think you got it.
Okay.
Would you like an ice cream machine with that? As a Google campus. Yes. Anything else?
Yes, we would also, if you can, it's not mandatory. We want to also implement some automation.
Okay, copy.
To be able to program these switches. We do have a network controller that you can add. You would have to access it via a PC. First, you'd have to give it an IP address and then access it through a web browser on a PC.
Yes.
Of course, access it through I'll show you how to access it, I believe, through.
Through HTTPS.
Yeah, exactly. Boom. So you know how to do it. So yeah, that's it.
Okay.
That's all we got.
Okay. Thank you. I'm really excited to take on this contract. I feel like it's within my wheelhouse. Obviously, I have a little bit of questions just to kind of take it slow and steady, but 6 hours should do it. So yeah, let me start. Let me start with the subnetting, just so I have a clear plan on that front. So, and I'll just talk it out loud. So what I'm thinking, I was just trying to thinking ahead of like not well, let me I'll drop the units physically, and then we'll go into the logical side. So
Okay.
so let me see if I have control. Okay, cool. All right. So I want end devices, and I'm doing okay.
Hey Ramsey, I forgot to include.
Switch runners.
We do need
Yes.
to test. Let me know when you're ready.
Yeah, thanks. Go ahead.
We do also need to test having a phone plugged up to the port and having a PC plugged up to a port at each of the building, and just make sure that traffic is still being able to be passed. Okay.
Yeah, I understand port security stuff. So IP phone for each building?
Yep, for each building.
Okay, so one IP phone for each building. Connected to a
Hey, Dave, let me ask you this question. I know you were talking about 23 end users. Would that be too much of a resource strain on this right here? Could he
Ramsey, what do you think?
could he actually mock, with maybe 3 users, 4 users, and maybe set up the IP addressing to cover that amount, since as a simulation? Okay, you see where I'm going, Ramsey?
I do, and I was going to kind of go down that once we get there, but yeah, we could have 3 examples, but
there we go.
We would have enough subnet space for say 36.
Okay,
we'll just call
it. That's good. That's cool. That's
the goal.
Because I'm just thinking about the real estate on the screen right now, and I can see it looking like a spider web after a little while.
Oh, that ain't nothing but a word. We could scroll this baby out.
Yeah, I know you can scroll up and down and sideways.
Oh no, we can scroll it out to where he has. Listen, look at this.
You mean like the zoom in? You zoom it, yeah, like it's a little dot. Yeah, I know it. Yeah.
Yeah. Oh, nah. You're right though. Yeah, so it doesn't have to be all. We don't want you to put in 20 clients. So just make an example for each site. Make sure we have voice. We have a phone plugged into a PC. We got APs, and yeah, we're good to go. And I'm probably going to ask you questions along the way, so just letting you know.
Yeah, questions will come at random. They may try to distract you, or something along those lines.
Hey guys, I'm back.
Okay, There you go.
Yeah, Nick card's on the way out. Something I have to replace after the CCNA. So do I have control? Yeah, there we go. Okay.
Yeah. Let me let Carlos in. Give me 1 second.
Copy that.
Here we are. Ramsey, give me 1 second.
Oh, copy. Control. Hold. Yes, please. Thank you.
I'm going to take control. Claude, I'm going to give you control so you can start letting people in. So Ramsey can just continue working.
Go ahead.
Let me see here.
That is. Mm-hmm.
All right, Ramsey, go ahead.
Thank you. All right, so I've got, gonna just start with the first building just to kind of think about this. And so let's say that I'm doing a 192.168, and I'm going to be doing, let me see, so 36. So it'll be 48. So
How many ports are on those switches?
good question.
Like a 24 right there.
Yeah, 24. So I'll be doubling up to get that 48. But I'll need a third one.
Are we okay? Are we using 100 meg switches, or are we using a gig port switches?
Great question. Budget, no problem. I would recommend the gig.
Perfect. I'll let you implement that since you're the engineer.
Okay. Like I said, I just don't know this super great.
And then Ramsey, just to let you know,
Yeah.
stepping out of scenario for a little bit.
Please.
There's different switches at the bottom. So like the 3560, 3650, those should be a gig switches, or the 2960, that should be a gig switch.
Copy.
Gig ports as well. So just take a look at all of them, okay?
I do. Yeah, I was trying to see how to see the configurations.
And you can go to the section that says CLI. There you go. And did you want the background in black? Will that help you out?
No, thank you. This is good. Yeah, I just.
Okay, cool.
Yeah, how is it? It's like trial by fire a little bit. So.
Gotcha. No biggie.
Like, how do I delete?
Yeah, I think you know by now. I gotta have my putty screens colorful.
So is there somebody I can ask if I have questions? Like, is Claude on the call, perhaps, something like that?
No, you cannot.
Or should I just ask out loud?
Nope.
Like, I just want to delete this.
You have your exam guide.
Well, it's going to be a long 3 hours. How do I delete?
Sure, I can show you.
Thank you.
So, click on this button.
Copy that.
And you can delete. One thing you do have to remember when you're done deleting, go back to this. This is the selector button. Okay.
Oh, yep. Thank you for that. Okay. And then there's a 24, I can see, and I'm gonna need, actually that'll be fine, because I just need 36 out of each. So I'll have that. And then we mentioned redundancy. So, well, sorry, I'm not gonna get ahead of myself. All right, so we got these guys. All right. So back to the subnetting. So 1 through so I need 36 total. So it'll be 1 through 45, because I want to pad it. Just wondering what's going to end up biting me in the end. So let's see. So let's just get cracked. Let's call this switch 1. And we're going to go to config. So we'll call this like building. Building 1 underscore top floor. Let's see, let's go save. Command line interface. Can, I think. All right. Okay. And then it's been a while. So all right, so I'm just seeing kind of what nothing's built, nothing's done. So that's lovely. Conf t, I'm gonna host name. I'm gonna call this build 1 top. And then, so let me see. So,
Hey, Ramsey,
yeah. Yes.
how you doing?
I'm good. I'm just thinking if I'm going to be like doing all the IP addresses for, all of these hosts, right? Like there's say several hundred. I want to set up DHCP with a pool.
Okay.
So yeah, there's just different things kind of running in the back of my mind of what's the best strategy for the use of my time to accomplish the agenda, and use the tools available, and not be afraid to kind of make it work. So yeah, just trying to get some momentum in this kind of awkward environment a little bit. So yeah, I feel like
Okay, let me give you this right here. Go ahead and set your mind at ease with the layer 3 stuff for right now. Go ahead and get your devices in place, make your connections. Okay, make your physical connections. The layer 3 stuff, let that be one of the last things that you worry about. Okay, make that be one of the last things you worry about. So the thing is, picture your IP addressing almost like you pouring water over top of a stack of stones. Okay. Once you get the IP addressing taken care of, it'll flow through the network where it's appropriate, if that makes sense. I'm trying to describe this picture to you.
Yeah, no, I'm following you. Yeah,
but the stack of stones are your components, all your devices put in place already. Does that give you a little idea? Give you a little sense of?
Yeah. Equating it to the OSI to start with the physical.
Right. You've heard that many times when David was instructing in previous videos and in previous sessions. So that's the one thing, we don't want to get ahead of ourselves, like you said earlier. So you're thinking, on the right track. You want to slow your mind down a little bit, so to speak. So get your physical stuff in place. Okay. get your basic configurations of your switches, host names, all that good stuff. You can get that taken care of first. You see what I'm saying?
I do.
I'm
Thank you for that.
gonna fade back out now.
And just as an aside, this is actually really fun. It's what I want to do, and so I'm excited to knock this out of the park in a slow and steady manner. So I've got my 2 rooms, but then again, the client requested redundancy, and so 1 switch won't be enough, and so we're going to go ahead and under network devices, go to our switches.
Hey, Ramsey.
Yes, please.
Hey, I'm glad you said redundancy. Are we just going to have 1 link between the switches? Is there something else we can implement?
Oh, right. Yeah. Ether channel.
What's that?
Ether channel would be where I am using multiple hard lines and turning them into a virtual link.
So what is that supposed to do?
It allows for fault tolerance and also load balancing.
Oh, okay. So when you say load balancing, it's going to separate my traffic throughout all the links?
Through VLANs?
I don't know. You tell me.
I'm getting ahead of myself. I think I'm yeah, I would be doing VLANs for security, and just that would be in the real world what I would expect. So even if they're all on VLAN 1, at least we have that protocol set up.
So let's pause right here, okay?
Yes, please.
Okay, so take a breather, all right? Drink some water real quick, okay? So I asked you those questions on purpose because whenever you get into the exam, they're gonna throw you doozies. They're gonna throw you doozies that has nothing to do with what they're asking you about. I asked you about ether channels, you're telling me about VLANs, right? You answered the question already. Redundancy and load balancing, that's it. Whenever you see a question and they throw doozies at you, stay on course. Keep it simple. Okay?
Thank you.
Let's keep rolling.
Yeah.
You're doing good, by the way.
Thank you, sir. Okay, so we're working on our ether channel, which is straight through. We're going to 2 to 2, and we're going from up straight through because of MDIX. We don't need crossovers because we have MDIX.
What's that?
It allows for, instead of having to flip the cables with a crossover, that the paths are 1 and 6, 2 and 3, full duplex.
Yeah.
Okay, so I got my ether channel on these 2 lines, and then here's my redundancy. And I'm trying to think of like the best way of incorporating them, like a mesh or okay, so I got my floors. So if I went up to here, went up to here, went up to here, went up to here, I'd have full redundancy, but I don't know if I. Okay. To me, this makes a little bit more sense for, I'm gonna go 1, 2, 2. This guy go. Oops. 1 to 1. 2. And then now I want to think about my redundancy. And so let's say if the ID, trying to think. So out of every building, you have your mainframe MF I think, and then you have MF something, and then you have your auxiliary on each floor. So just trying to think of.
Keep it simple.
Copy. So I'm
You're
gonna
doing
run,
good, by the way. Just keep it simple. Okay.
Yeah. Just trying to figure out the signal flow. Hadn't done this before, so I want to send my signal. So I like systems in place. I like, to do things in a particular way so that it's very kind of loggable and makes sense to the next person. And so just thinking about allocating whether it's a full mesh or what type of ability to get these to interconnect in a way that makes sense. And so
That's fair.
I could use some help. I can guess my way through it, but I'd love some insight practice.
Okay, let's think about this, right? We're both engineers, right? Okay, so we have right here, right? We have 4 floors, right? Redundant switches on each floor, right?
2 floors with redundant switches.
Okay, perfect. Yeah, so 2 floors with redundant switches. So that's building 1, and I'm guessing how you got to set up the bottom 2 ether channel switches are building 2. Is that correct?
Oh no, sorry, my signal. It's the NIC. I got to replace it. So yeah, go ahead. Sorry, I lost you. I thought I lost you.
No, it's all good. It's all good. So you said the first 2 bundles of switches, they are building 1, and the 2 bundles at the bottom is building 2. Is that how you got it set up?
I was thinking that floor 1 and floor 2 of the first building. Yeah, so I was thinking on the main floor, or floor 1 and then floor 2.
Okay.
Mm-hmm.
Okay. And you said you want to do a full mesh, correct?
Yes. So
cool.
it'd be
So what's a full mesh?
Yeah, it would be an X pattern in this situation on both, and then
cool.
Great. So 3 goes to 3.
And we're going to have a redundant links for the full mesh for each switch.
Yes, in a perfect world.
Yeah, in a perfect world.
4. And let's make some room down here for these kids. 3. It's like a documentary runs in the back of my mind. When did Ramsey know he is in over his head?
You're not in over your head. You're doing good. Keep rolling. But Ramsey, I did have one question.
Please.
You ready?
Yes.
Cool. All right. So we have a full mesh. Great design, by the way. Can we discuss how spanning tree is going to operate now that we have a full mesh between switches?
Yes. So spanning tree will want to create a designated. Well, it's going to turn off, a redundant link. Trying to blank on the name. It's a block. It will block the redundant link.
Okay. And what's the goal of it?
To avoid layer 2 broadcast storms.
Okay, that's one piece of it. Keep going. What else is the goal of the spanning tree?
To avoid broadcast storms and.
So if I have a PC connected to switch 7, right?
Yes.
Okay. And I want to send, let's say we have the server connected to switch 10, right? Let's say we have a full mesh of all these switches, right? What is spanning tree doing to prevent traffic coming from my PC to go to each other switch and coming back to my PC rather than going directly to the server on switch 10? What is spanning tree's job? What is it meant to do?
The root bridge.
Stop guessing.
Yeah, I want to say prioritize traffic into a direction through the best route.
Keep going. Keep going. That's exactly it. That's exactly it. Keep it simple. One path. We want one path with redundant links between our switches. That's it. Okay? What's the first part? What's the first part of a spanning tree convergence?
Initiate.
What are the switches going to do?
So the switches are going to send BPDUs. I'm sorry, they're going to send hello packets. And once a switch receives a hello packet, it will go into initiate. And then
Stop. Layer 2. You were right the first time. It's sending BPDUs. So it's sending BPDUs. Now what are we doing? What are in those BPDUs from each switch? What's happening?
Drinking water.
No, go ahead. Go ahead. All good. All good.
I know, but it's like.
You're doing good, man. You're doing
Thank
good.
you. I actually had to write out just all the interconnections between all the different protocols a while ago. I ended up like 50 pages just because it's real easy to get lost in the alphabet soup. And so, BPDUs, yeah, I'm kind of circled around a little bit.
Okay, so let me help you.
Yeah.
Right? It's all good, right? So So we're engineers. Let's think about this together, okay?
Mhm.
So you stated, and I agree, that the switches are going to send out BPDUs, right? So if we have switch 7, switch 8, and switch 4, they're sending BPDUs, right? We have what's included in those BPDUs, right? The bridge ID number, okay? Because as soon as the switch sends out the BPDUs, it thinks that it is the root bridge and it's the best switch in a topology, okay?
Yep.
So with that being said, right, it's going to receive BPDUs as well, right? So what is going to happen if it receives a BPDU from a neighboring switch that has a
higher
inferior BPDU or superior BPDU? Tell me both answers.
Yeah, so if it's
First
superior,
then
yeah,
superior.
if it's higher, then it'll accept that as it'll accept it. Whereas if it's lower, then it stays.
What do you mean accept it?
Right. I'm running into a little bit of a fog. It's funny because I know this inside and out. So
this is how the test is going to. This test is going to make you real foggy the day of.
yeah, I hear you. So I'm kind of I think what I'm getting kind of caught up with the route and the switch and kind of which one does which. Like this is all switch stuff, but I feel like I'm missing something. That's why I'm kind of catching myself confused. So isn't it the router ID that we want? Bridge ID. Yeah. So I just had the wrong word in my head. Yep.
No worries.
So yeah. So we'll want to set the bridge ID, the one that we want to be the designated. Then why do I want to say DR?
Because you're thinking about OSPF.
Think about OSPF.
Okay. And that's why I'm kind of
that's why I told you
turned around.
Yeah, remember I said just leave the layer 3 stuff. Don't even worry about that right now.
Keep it simple. Keep it simple, Ramsey.
I know. I'm just trying to figure out what's the technology for layer 2. Like I'm just having a blind moment there. So for it's not OSPF. We're talking about right. Everyone pour yourself a drink. So okay, so just to kind of follow the train. So yeah, so I'd set the bridge ID. Let's say there's 4 of them. So I'd set the one that I want to be the designated bridge to be like 4444. And that one would take precedence. The only thing that there's a priority number takes precedence of that, and then under those is the loop back, and then it would be highest IP address. So
why are we talking about layer 3?
So so the bridge ID is what I'd want to set if I had a preference as to which would be.
So
yeah,
what you're meaning to say,
thank you,
is you're meaning to say the root bridge, not the designated bridge. What you're meaning to say is the root bridge.
yeah.
Okay.
Thank
so
you.
Now remember this. We can, as engineers, we can determine and we can set the root bridge that we want to be the root bridge.
Mhm.
Okay, we can either let the switches figure it out amongst themselves, or we can pretty much tell those groups of switches, this is going to be your root bridge here.
Mhm.
Okay, now you have that choice to set it up here as you see fit. Okay,
Mhm.
but David also wants you to understand that process of that selection, how that happens. And you talked about priority.
Mhm.
You talked about root, the root bridge. You know how that plays with the MAC addresses. You understand how that plays with the priorities. Okay,
Mhm.
so you ask yourself, do you want to go ahead and let those 4 switches determine amongst themselves who wants to be the root, or do you want to go ahead and make that decision for it and set the root yourself? That's a choice you have.
Mhm.
Now, if you set it yourself, there is a specific command that goes along with that.
Yes. Yeah, it's root ID bridge.
The majority of those commands start off with show spanning tree, something, something, something. So you've probably read your books and you've probably seen a lot of commands that said, spanning tree, blah, 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 blah.
Protocols. Yeah. Right. So we're at the fork in the road of setting it up or letting it do it dynamically. Is that right?
That's your option. That's your
Yeah.
option.
Yeah. So I think
Before we
I would
go
like
back
to
into
set
the
it.
design,
Mm-hmm.
let's. I just want to go back to my question
Mm-hmm.
because again, you're going to see this on the exam. What's going to happen if a switch receives an inferior BPDU and a superior BPDU? As far as convergence, tell me what that means.
Convergence means that all of them have the same. Oh my God, forgetting the word.
No, it's all good. It's all good. Let me explain that to you. So convergence meaning that it creates one path throughout the redundant topology. Okay, so meaning
Yes.
it elects its root bridge, it elects its designated switch, and its non-designated switch, and it blocks the port, or what have you, right? But first, it needs to elect the root bridge. What is happening before any election process, right? You stated, you were right, you're on the right path. Every switch is sending and receiving BPDUs.
Mm-hmm.
What's going to happen if it receives a superior BPDU and an inferior BPDU?
If it receives a superior, then it adds that information into the BPDU that it sends out. And if it's inferior, it ignores it.
Think about it like this.
Mm-hmm.
And this may not even be in your textbooks, but every switch that's on a network, when they first start up, when they first power up, every switch thinks it's the big dog.
Mm-hmm.
Every switch thinks it's the big dog. Okay. So a switch comes out the gate thinking it's the root bridge already. Like David said, they got to send these BPDUs. This is how they communicate with one another to find out who actually is the big dog. So if Ramsey, if you think you are the big dog in this group right here, okay, you standing firm, you sticking your chest out, you sitting there talking about King Kong don't got nothing on me. All right.
Mm-hmm.
If I send you a BPDU that is nowhere near your current status, would that be a inferior or superior BPDU?
Nowhere near my status.
Yeah.
feel like that's ambiguous. It could be
Okay.
either.
All right. So let's just say, okay, you got a bachelor's degree, you got 3 certifications, and you got an honorary mention at the local yacht club.
Okay.
Okay.
And this guy?
So your community knows you as that. Okay.
Yes.
I come and I'm presenting myself as a high school dropout.
Okay.
I got a rap sheet that's like 6 miles long. Okay.
Uh-huh.
So,
So
but
inferior.
okay, so that's inferior.
Yes.
So now, would you still continue to have that feeling or that notion of you're still big dog in charge?
Yes.
Okay, so that's me sending you the inferior BPDU. All right.
Yes.
So you've acknowledged me as the inferior switch. So you still maintain your thought of you being the big dog. Follow me?
The root. Yes.
The root bridge. All right, let's just use the real terms. All right, because David knows I'm one to use them layman's terms. Let's use the real terms. All right, so the root bridge. So you receive 2 other BPDUs that's similar to mine's. How do you look at those compared to your status?
Again, they would be considered inferior. So I would.
Okay. So you still maintain your notion of you are the root bridge.
Yes.
Now, you receive 1 BPDU from somebody who has 3 PhDs. Okay. They also have a 5-year resume track of doing what is it, Doctors Without Borders?
Sure. Or a priority of something higher.
Okay. Right. And they also know in the community because that person also went up a tree to save little Peggy's cat that was getting ready to jump one day.
Made the newspaper. Yeah.
Made the newspaper. So how would you take that BPDU and put it up against your status?
Right. So I would add their information into my BPDU and send that out.
So just back it up a little bit. So would you consider that to be a superior or an inferior BPDU?
Superior.
A superior. All right. So with that being said, what do you do with your notion of you being the root bridge at this point?
I would yield to the bigger dog.
Right. That's how the election process happens in basically what I just explained in hood fashion.
All good. But even if I'm inferior, I'm still I'm updating it with, right?
You're still
with the big dog info.
Yeah, you're still sending. Yep.
So that all jives with my understanding of it. So yeah. And I get the priority, or the priorities. And I feel like, in a perfect world, we would set those up, but in real world, maybe it's done dynamic just to save time. So I don't know. But in this situation, I would set it up real quick. I would just have to noodle around to get that command, and then I would just run around and knock it out to all 4 of these. It's right on the tip of my tongue. It's something ID, dash ID, bridge ID. But I would do a question mark.
Yep, there you go. Bridge ID.
Yeah.
The old term for a switch is a bridge, so they just kept that term there. So it's a bridge ID. Okay.
Now.
So.
No, to do that. Oh, sorry. Oh, I was just going to say, even to do that, do I need to set up IP for the interfaces, or?
Layer 2.
Right. So I can just set up the bridge ID and move out.
That's it.
All you need to do is just plug in cables. They will do the rest. Simple as that. If you want to manipulate it as an engineer, like you stated, you can change the bridge ID by changing the priority. You can't change the MAC address. You can change the priority. You can manipulate the bridge ID there. Okay? No IP addresses.
Yep. And my only thinking of setting it up with the Bridge ID would just so that I know if it's working or not to a certain extent. Like, you know, I can predict the behavior. Otherwise, I have to do a little bit of digging and figuring out what it decided to do to then figure out if it's predictive behavior. So yeah, just kind of talking that part out. But
no, all good. All
yes,
good.
sir.
All good. So we're continuing with spanning tree. Okay. So there's different kinds of spanning tree. We're going to keep it at per the CCNA.
Yes.
We're going to talk about STP and RSTP and RSPVST. We're going to keep it simple.
PVST.
First thing first, we're talking about convergence, right? So we plug in a cable, right? And it's switching between different states before it starts passing traffic. Can you tell me for spanning tree 802.1d, what are the 5 states that it goes through?
Yes. If you're down for a 2-way, then initiate. That's the way I remember the first 2-way. And then you have full, and in between 2-way and full.
OSPF.
Yeah.
You're thinking about OSPF.
You're thinking it's different. You're thinking of the 5 states that's, yeah.
Oh, yeah. And that's just brain fog. I'm really kind of.
Man, you must really gonna knock the OSPF stuff out of the park. I tell you gonna knock that stuff out of the park. I can see it now.
That thing is gonna be, listen.
Okay.
I need to hook you up with my
So
boy.
spanning tree protocol.
OSPF engineer right now. Okay, so
let's slow down.
Remember.
So spanning tree.
There you go.
All right. So STP. Kind of looking for a clue to get me back in that world. For spanning tree.
Okay, so everything starts. Okay, everything starts at a disabled state when you're thinking about regular spanning tree.
Oh, right.
802.1d.
Yep. Okay, thank you. Yep. So yeah, we have disabled. Okay, so yeah, for the different ones, they have different terms, whether they're listening or learning, but blocking, forwarding, block forward, right? Disable, block. It's block. Alternate is in there somewhere, but
okay, well, just back it up a little bit. Just back it up. Just slow it down. All right.
Yep.
So just remember 802.1d. We started off at disabled, and then we go to what's the next step it goes to.
Listening.
Before we get listening, we're blocking first.
Right. Yeah.
Cause see, the thing is, we don't want to come on immediately and start letting stuff through. We don't.
Right.
Yeah,
so
we don't want to do that.
Block.
Right. We want to block first.
And during.
So when we're blocking, what we're ultimately doing is we're ignoring incoming data.
That's right.
Okay. Yep. So after that, then what are we doing?
Then we're listening while still blocking. We're just letting packets come through.
Right. So what happens is we're listening to the switches around us. Okay. Because like I said, we're still exchanging BPDUs amongst the switches. Okay. And at this point, there's no MAC learning yet, and there's no forwarding going on. Because like I said, we're still listening. Okay. So after we do that, then what do we go to?
I'm drawing a blank.
After we stop listening,
right, and before forwarding. So, learning.
Right, and at the learning process, at the learning step, what are we doing?
So listening would be in a passive mode. Learning.
What are we learning? What are we learning at that point? We're learning to see if we're learning to see if
please, thank you.
Yeah, we're learning to see if Claude's Vista machine is connected. We're learning to see if we got some other PCs connected. So we're learning MAC addresses. At that point, you know, now we're starting to build a CAM table now at that point. Okay.
Whereas in listening, we're not building, we're just
right,
in a passive state.
Because listening, we got to figure out what we got to do first before we just jump to conclusions. Okay.
Copy that.
But like I said, in the learning state, we're learning MAC addresses. Now we're still not forwarding nothing. We're still not forwarding nothing, but we're learning MAC addresses. We're building our CAM table. So if you think about the processes that Dave took everybody through during previous sessions, and when we start checking to see if those VPCs, if their MAC addresses were being learned by the switches they were connected to, that happens in that process right there. Okay. And then once we learn and we got those MAC addresses in our tables, what's that last step we doing?
We'll forward out the appropriate ports.
Right. So we're stable and we got MAC addresses learned and we are now forwarding traffic.
Yep, via the right ones. And so, yeah, and then for your ports, you have root port, designated port, and then block port. Yeah.
Cool.
Yeah. So thank you. Yeah, kind of. How's it? It's kind of went off up here.
Yeah, it's happened.
It's like I can't get back. I went too far. Get me back over here. So
it
yeah,
happens.
thanks for calling me back. Yeah.
Happens to the best of us, bro.
Yeah. Yeah. Good. Yeah. So how can I help, or what should I?
So what we're gonna do now, here's what I want to do. We're gonna break here. Okay. I'm sharing. Hold on. Where's my? We're gonna break here, right? Here's what I want you to do. Look over the layer 2 stuff. I'm confident you know layer 3. I need you to look over layer 2 stuff.
Okay.
Know the terms, know convergence. We're gonna have a session tomorrow. I didn't plan on it, but I want you to pass the exam. Same time, same place. I'm gonna ask you the same questions.
Okay.
Okay.
Yes.
All right, Ramsey. By the way, you did an awesome job tonight. We're gonna fine tune some stuff. Come tomorrow. I know you're gonna bang it out the park. Okay.
Just gotta breathe. Just gotta breathe. You know. Just gotta breathe.
Yeah. One is just. Oh, sorry to cut you off. But yeah, it's just a different orientation. You know, like I have a little bit of a disability of like cognitive figuring stuff out, and so that's why I was like, for this test, I'm just going to only focus in this one way because that's how I'll be tested. But here, it looks different, it smells different, you know, and so I knew I was walking into something. But yeah, this is great. And the thing is, it's all interrelated, and so the ability to pickle, you know, out of one protocol and go into the other, like, okay, now we're doing time management, you know, like within TP, and then, okay, now we're doing over here. Like, that's what is going to really help me for the interview, because the whole point of the certification is to get a job. So,
yeah.
You know, so I see the wealth.
Because in the interview, unfortunately, they're not going to ask you the question in the way that the test puts it. You know, so that's where you'll hear people refer to as, okay, you got good test takers out there, and you got people that really understand the subject matter. And when you understand the subject matter, you can come at that individual from many different angles and you're not going to stump them. You're not going to stump them, you know.
And that's how I am with AV, you know,
okay. When you know your stuff, you know your stuff. Yeah. So that's what David wants you to grasp, you know. There's more than one way to skin a cat, as they say.
Yeah.
You know.
Butter knife.
But you got to be able to recognize it, you know, when it's coming.
Yeah. Thank you.
Yeah. All good. So, Ramsey, I think you got your marching orders. Just roll with that. Send me questions that you have throughout the day. I'll answer them. Send to me, Claude, the group, whomever. Before tomorrow at 8, I'll answer them. Just remember, of course, I can't speak on how the exam is because of my NDA. But memory is not going to pass the exam. That's not going to be your only tool, okay? Got to use those skills, okay? I know you have them. I've seen it, okay? So take some time out, breathe, relax, kick it, and let's come back tomorrow, okay?
Sounds good. One thing is doing the doing the ACLs. I'm good with the basic ones, but when there's topologies involved and there are word questions, that's when a little bit of concern, right? Like I'm not hitting that 100 out of 100 on them. So yeah, if we could just kind of put a feather on the hat of that. But I'm comfortable with it. It's just there's something somewhere when we scale up that I'm not hitting. So yeah, it would be great.
We'll keep it simple. I'll keep it simple tomorrow, okay?
Cool. Yeah, whatever's appropriate for this CCNA. Like that's the thing. It's like I don't want to get caught in the weeds if I don't have to. So.
Sounds
but
good.
Thanks, guys. Yeah.
All right, brother.
Does anyone have questions? Did you guys want to do Q&A bits or?
I have a question.
What's going on?
On a scale of 1 to 10, how stressful was it?
For me?
Uh-huh.
Yeah, I got really hot all of a sudden. I was just like, oh God. And the thing is, I know this stuff inside and out, but I couldn't get back in the car. It's like I locked the keys in the car and I couldn't get in. And so that's like that army thing of you just practice. Because when your brain becomes a peanut, you know, it's same with when you go on stage or you do a big show, it's like your brain becomes a peanut. So you can do one thing really good. And I kind of locked on to OSPF and I just couldn't get out. So yeah, good experience.
So what would you say, like just based off this particular experience, like what would you tell somebody else, I guess, in this particular situation? Like what would you have done like differently in this particular thing?
Interestingly, the only way to get good at shooting a gun is to shoot a gun. And so I would say that this real environment is the place to practice it. There's just nothing I can do on my own in reading and talking out loud that will, for me, help, because the book smart is there. It's just when I'm in a different, so here it is. And this is what I'll be doing is I'm going to open up the software and go through the whole thing on my own. And then that way I have the practical experience of doing it recently. And that's what I was missing. That if I had, because there's people, Ala, I think her name is, she's building topologies left and right. And I would say that that is the best method to get it, you know, inside and out. And that would have saved me.
Yeah, she's really enthused about, you know, the whole networking industry right now. So she's all ablaze for that, you know, and that's big kudos to her, big time.
I absolutely love her notes. Like her notes are just like
Yeah, I told her about those colors. Yeah. I
Between the
told her about those
colors, the
colors.
graphics, the hand drawn stuff, I was just like, golly, like my brain does not think like.
It's taking ownership of it, you
Yeah.
know, and the
Yeah.
thing is, that's a marketing tool. Like,
Yeah.
you know,
That's what's going to make her unique. Yep.
She's definitely gonna be valued.
practice.
So
Yeah,
yeah, I think she's gonna be great.
yeah, but as the guinea pig, you know, and I'm sure there's, you know, obviously guinea pigs before me, but just if you have the time, you know, opening up the software and building up that layer 2, you know, spanning tree setup and you know, physically doing it will really help for when you're called to action for it.
See, and I think the same thing kind of in reverse with like cybersecurity. Like like last night I got caught up and I kind of kicked my own self out of my system. So and couldn't get in. When I tell you I did so much troubleshooting last night, bro, my head was hurting. Like I think I started playing around in it probably about maybe 1-2 o'clock that morning. And then like maybe when I posted in the chat, that was when I finally, it clicked to me, everything figured it out. Like if you can't do it through the computer or you've exhausted like SSH into the system, you've exhausted like checking all your cables, checking your connections, checking the system, making sure the ports, everything is plugged into the right place. All of that stuff is good. And I still can't get to it from my computers. I decided to go to my server, plugged up the monitor, plugged up the keyboard and the mouse, and just kind of navigated through the menu there, and found my management nick, which I knew that was what I messed up. So I just couldn't figure out how to fix it. So no article was helping me. So I was just like, okay, I can't find it this way. I'm gonna just start playing around with stuff on the Switch. I can't break it. So I mean, if I break it, I could rebuild it or refix it or whatever it may be, but I definitely don't want to go that route. So I found it, the management adapter or management nick area. So I was able to change it over to the right one, and boom, logged in. I went to my internet browser, typed in the IP, went straight to my ESXi console. So yeah, it's a lot of troubleshooting and digging and looking, and also making sure you write down your configuration. So once you got it right the first time, if you have to go back, or either snapshot too. If you have to go back, you got a starting point. If you don't do that, then I mean, you just asking to start back over again. So.
Yeah, thanks for that. Yeah, something I learned in AV is everything you do, you should be able to answer the why question.
Yes.
So, you know, why are you doing this IP address? If you're just kind of willy-nilly around, you're gonna get painted in the corner. So
yeah. And I found out my why because I started looking up exactly around that range of what it was, how I changed it, and why it kicked me off. So doing that, because you disconnected the nick that was connected to the actual, that's going to get you to your internet browser, to that specific IP is why it kicked me off. So yeah, you ain't got nothing to connect to. So now I had to manually go in and redo it, and add it back. So yeah. So yeah, that was my learning lesson.
All good. All good. All good. All right, fellas. We're coming up on that hour at 9:30. Quick tidbit. I just want everybody to remember, Ramsey, including you. You know, whenever you're thinking about anything as far as the CCNA, talk about it every week. OSI model. Take it slow. Okay. Take it slow. Talking about layer 2, stay at layer 2. Layer 3, we'll handle that somewhere else. We're not talking about layer 2 yet. We're just talking about making connections. Let's stay at layer 1. This is not just for Ramsey. This is for everybody. I've seen it. I think Claude knows. I've been troubleshooting a damn layer 3 issue with an engineer, and he didn't even check layer 1 or layer 2, and it ended up being a layer 8 issue, right? But Slow it down for everybody. This is not just a Ramsey. I've made this mistake as well. The OSI model is there for a reason. It's not just to look good. It's for a reason. Use it as your advantage. If you ever get lost, layer 1, cool. Layer 2, perfect. Layer 3. And on that note, fellas, you guys have a great night. Okay?
Night, everyone.
Okay.
Later, folks.
Y'all have a great night, all right?